Okay, again, I cannot pronounce common words correctly sometimes. I have a tongue tie. That being said, this episode is about why can't we just use magnetic propulsion? And I am gonna be really struggling over that last word with this tongue tie, unfortunately. So, why don't we just use magnets to launch rockets into space? It seems simple, right? Well, no. And here's why physics laughs in your face, unfortunately, every time you try, and I wish it didn't. Trust me, I wish it didn't. So the first part of this video is the core problem. Gravity plus escape velocity. So to get off Earth, you're fighting gravity. And gravity is winning until you hit escape velocity, which is about, I believe, 25,000 miles per hour. Feel free to fact check me. The breakdown on this is the Earth pulls everything down with a force we call gravity. To leave Earth's pull, you need to go really fast. That's escape velocity. Okay? So you don't just float up like a balloon. I wish it was that simple. I really do. You have to punch through the atmosphere at rocket speeds. So a fun fact is that's why rockets burn so much fuel just in the first few minutes of flight. They're using insane amounts of energy just to get moving. Part 2 of the video is what about, magnetic or EM propulsion? Well, magnetic propulsion works. Kind of. Just not in the way you think it does. So the breakdown is EM propulsion systems do exist. Think of ion drives. And, oh god, I'm going to slaughter this word. I don't even know if I'm pronouncing it right. Magnetic plasma dynamic thrusters. That is a big word. And I'm so sorry. Basically, they work in space, but not from the ground on Earth here. They're used for in-space maneuvering, not for launching. And why? It's because they produce tiny amounts of thrust. Great for long trips, unfortunately terrible for liftoff. So a good analogy is EM propulsion is like a slow but steady electric scooter. Rocket launch is like strapping yourself to a stick of dynamite and lighting it. That's the easiest breakdown I have been able to figure out how to explain that entire thing. Part 3 of the video is why magnets can't just lift rockets. God, I wish it was that simple. Trust me. We'd have so many more advancements right now. So you need an electromagnetic rail system powerful enough to launch thousands of tons instantly. The heat and power demand would be astronomical. So the breakdown is a rocket weighs hundreds of tons with fuel and the payload, right? So to launch using magnets, this is what you would need. You need a launch rail several miles long, okay? You would need a superconducting materials cooled to near absolute zero at the same time, and then power systems we unfortunately have not invented yet. So even if you built that, you'd still risk frying your electronics and your entire crew during launch acceleration. So fun fact, the G-force of a railgun-style launch would likely kill humans unless you made the track comically long, like dozens of miles. Yeah, G-force also plays a fun fact in this. Part 4 of the video is fuel is still king for liftoff. So until we invent anti-gravity or space elevators, which please, I really hope that happens in my lifetime. I love nothing more. Chemical propulsion is still the only way to reach orbit. So the breakdown is rockets burn fuel to push against gravity. That's what gets them, woo. Okay? Simple terms. All other tech, magnets, lasers, EM pulses, don't provide enough push fast enough to beat gravity plus the air resistance. You need to thrust to weight ratio over 1 to lift off. Magnets don't cut it yet, and I really hope we actually do build something in the future because I'd love to see that happen. Part 5 of the video, so when will it be possible? Well, it's when our tech gets better. Maybe a century from now, but we're not there yet. We're not even close, and I wish we were. One of the main limiters for tech innovation is those who are in poverty, who have high IQs and love the STEM sector, just can't afford the schooling to be able to get into the innovation sector, and that is the huge issue we are having. So until that changes first, innovation's kind of stagnant. So the breakdown is, this is what we need. We need room temperature superconductors, okay? We would need massive power grids in orbit and or on ground based. new materials that don't melt or rip apart under stress. And then we also need safer launch platforms that don't crush the human body with G-force. That's the other important part. So until then, unfortunately, rockets are very messy, very loud, very dangerous, and unfortunately necessary for space exploration. So you can't magnetically yeet a 300-ton rocket off Earth. Not yet. God, I really hope if we ever get that technology, someone just yells, 5, 4, 3, 2, 1, yeet! I really hope so, because that would just make my day. Even if I've expired, I will be watching and being like, yeah! Because it's funny. It's funny. But this isn't sci-fi, it's physics. And physics, unfortunately, doesn't do shortcuts. And I really wish it was simpler than that.